Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTE 2311 Signals and Systems Analysis. In this video, I will talk about Introduction to Laplace Transform. Okay, so I will talk basically about Laplace transform, some basic equations related to the Laplace transform, the Laplace transform table, and some sample problem. The Laplace transform is a tool that is used to map the signal and system's behavior from the time domain to the frequency domain. Okay, so the time domain is the t domain that we always see in our study before. And now we will look into the frequency domain, which is the s domain. Okay, we will look starting from this chapter. So let's say you have a system that accepts an input x of t, and it has an impulse response of h of t. Okay, so after some operation between these two signals, you get an output, say y of t. Now, if this input x of t undergoes a Laplace transform, so this L here symbolizes the Laplace transform. So this x of t become capital X of s. And so this is the s now is the frequency domain. Okay, again, the impulse response become h of s. So your output will become capital Y of s. Okay. So if this output undergoes the inverse Laplace transform, okay, so this capital L to the power of -1 symbolizes the inverse Laplace transform, we will get back the output in time domain, which is Y of t. And so the Laplace transform expresses the signals as linear combinations of complex exponentials, which are the eigenfunctions of the differential equations that describe the continuous time linear time invariant system. Okay, so the S is actually, if I just change this to a pen, this S is equivalent to sigma plus j omega. Okay, this is the eigenfunctions of the differential equations. Now, some basic equations related to the Laplace transform. First one is the Laplace transform itself. Okay, let me just change back. So we have here, okay, the Laplace transform of x of t, which is equivalent to capital X of s, equivalent to is an integration from -infinity to infinity of the signal multiplied by this exponential signal dt. Okay. The second equation is related to the inverse Laplace transform. Okay. So we have the inverse Laplace transform of x of s equal to this equation. We will get back xt u of t. Now this signal x of t multiplied by u of t simply means that this signal, okay, for when t equals to 0, okay, so x of t, let me just change back to pen. So it simply means that x of t is equals to 0 when t is smaller than 0. Okay, so if you look at the graph, for the value, for the value of the signal over here at t is smaller than 0, it will be 0. So that's why it is multiplied by u of t. So this table shows, okay, some Laplace transform of some basic signals. Okay, so we have an impulse signal. The Laplace transform is equals to 1. So this result can be proven if you do the integration using this formula. Okay. So for the step signal, the Laplace transform is 1 over s. Okay, so these are some of the basic signals and their equivalent Laplace transform. So we can use this table, okay, to do Laplace transform instead of performing the long process of the integration. So let's have a look at two problems here where you are asked to determine the Laplace transform of these two signals, okay, using the Laplace transform table. So if I open the whiteboard, so these are the two equations. The first one is x of t equals to e minus tut plus e minus 2tut. So if we look back at the table here, we can see here e minus atut. Okay, so if we have this signal in the time domain, the equivalent Laplace transform is 1 over s plus a. So if you look here, means x of s equals to this one e to the power of minus t, which means the a is equals to 1. Okay, so we have 1 over s plus a is equals to 1, so s plus 1, plus e to the power of minus 2t. So this time here 2 is a. Okay, so we will have 1 over s plus a, s plus 2. Okay, this is the Laplace transform by referring to this table. Okay, the second question, we have 5 sine. Let me just bring this up a little bit. We have 5 sine 2t ut. Now if we refer to the table, for sine omega t ut is omega over s square plus omega square. And here, if we look at the equation, here, our omega is 2. So our x of s is equals to 2 over s square plus 2 square plus 4, right, which is this one, right, omega over s square plus omega square, and this omega is multiplier to t, so this omega is 2, so we have 2 over s square plus 4. Okay, so that's all for the video this time. I will see you in the next video where I will talk about properties of Laplace transform. Thank you.